Welcome to the video that's going to explain autonomics and the autonomic nervous system and how it operates. Now, you probably know part of this already, but we're going to go through the basics and then how those upper centers in the brain influence the autonomic system. So, the autonomic nervous system, it has two parts to it, the sympathetic and the parasympathetic system. Now, sympathetics are the 4 F's, right? Fight, flight, freeze, and reproduction. Parasympathetics are going to be your rest, repose, voiding, excretions, digestion, salivation, all those things that you don't need if you're running from something. So the classic example is running from a tiger or a bear, and that's your sympathetic system. What do I not need as I'm running from that? Digestion or anything like that. I need blood to be shunted to my muscles so that way I can run away from this. Now, the other way to think of it is sympathetics as the gas, parasympathetics as the brakes. All right. Now, one thing to know about this system is all neurons must synapse before work is going to be done. So it's a 2-neuron system, always. Okay. And so as we get into this, you're going to hear about different neurotransmitters. At the beginning, all of these preganglionic fibers, before they synapse, are going to use the same neurotransmitter. And then afterwards, they're going to split and do some different transmitters that way. But they all start somewhere. And so we need a central area where all this information comes back to. And there's a couple of places that control these responses, and especially our reflexive responses to that. The first is the hypothalamus. So located in the diencephalon, the hypothalamus is really going to be your primary command center for all these reflexive activities. So it's going to bring in a constant flood of information, and it's going to coordinate this neural and hormonal or humoral response to everything that's going on. And so think about the hypothalamus being your temperature regulator, right? Your thermostat. And so this is going to trigger sweating, shivering, vasoconstriction, vasodilation, all of those things to try to keep your core body temperature where it should be. It's also going to do water balance. So it's going to use osmoreceptors, so that receptor of how much water we have in the system, to define thirst, and if it needs to, it'll secrete antidiuretic hormone to try to level things out. It's also going to influence your metabolism and hunger, and then finally, it'll help control those or convert those emotional responses into reproductive responses later on. Now, also part of this is the brainstem. So if the hypothalamus sets the goals, the brainstem continues the reflex. All right. And so it's going to do this from a couple of different ways. All right. So it's going to have cardiovascular control, usually from cranial nerve 10, vagus. All right. Vagus, our wanderer. Vagabond comes from that. And so as it wanders down, it's going to create this vagal tone over our heart. It's going to keep it around 60 to 80 beats per minute. All right. All of this is from our cardiac center here. It's also going to do respiratory control, as well as it's going to influence our digestive reflexes, such as swallowing, which is a plexus of cranial nerve 9 and 10, glossopharyngeal and vagus. Salivation, which is going to be cranial nerve 7, which is facial, as well as cranial nerve 9, glossopharyngeal. It's going to assist with coughing, and also your vomiting centers are up there too, your emesis centers, right? And that's cranial nerve 10 as well. We also need to monitor blood pressure, and part of this is through using our autonomics, primarily cranial nerve 9, it can be 10 as well, in response to these baroreceptors and chemoreceptors. So you're going to see cranial nerves come back. They're going to bring back that afferent, that sensory information up to these centers, and then it will respond the way it needs to. It's going to do this through the nucleus of the solitary tract, or nucleus of solitary tract, all right? All incoming visceral sensory information will terminate there. It's in the medulla, or medulla, whoever you talk to. And this is distributed then to all the centers. So we're going to have this constant feedback from our arteries, that stretch on the arteries, so that way we know what to do. And it does it through this. It's going to detect what's happening first, and it's going to do that through its afferents, so that sensory information coming back, which all glossopharyngeal, not glossopharyngeal, all autonomics are going to have motor and sensory on them, general, visceral, efferent, and afferent. And so it's going to bring back that sensory information. It'll go back to the central integration, which is that NST, nucleus of solitary tract. Then it will kick in that reflex, The reflex will have an action, whatever that is, to stabilize it. And then we're going to have homeostatic restoration. But this is a constant loop over and over and over and over again. So you got the cortical limbic system, this mind-body interface. And this is going to indirectly access autonomics via the hypothalamus. So it's going to use memories, the situation, those kind of things to get going what it should go. So think about if you're really, really fearful or scared, you're going to shiver. Some of that is from this system. Blushing is another reason this comes from this. So embarrassment comes through here, or nervousness, and then we tend to flush. You also are going to have some spinal reflexes as well. So as we go down, you know that there's some in the brainstem. As we go all the way down to the sacral parts of our spinal cord down there, you're going to see different reflexes, such as micturition and defecation. So micturition is voiding or going pee, right? And so you can see that we have parasympathetics that go through the pelvic nerve or assist in the pelvic nerve, and that is going to be voiding, all right? So we use parasympathetics to go to the bathroom, all right? Sympathetics are for holding, all right? They're going to do this via the hypogastric nerve, and it's going to hold the urine there. And then you're going to have your own decision, right? So most of us can hold our bladder when we need to. That's because of a voluntary control. Again, just to look at the architecture, this is a 2-neuron chain system. It always uses 2 neurons. So it needs a synapse, needs to change the information in order to do work. All right. So we're going to have 2 different fibers, a preganglionic fiber and a postganglionic fiber. That preganglionic fiber is going to be from the cell body all the way through to where it needs to go. And then it's going to go to a peripheral ganglion somewhere. All right. And so if it's sympathetics, usually it's the chain ganglions, the paravertebral chain ganglions all the way up and down. If it's parasympathetics, it's going to be around the organ. All right. And so because of that, the length for the sympathetics for these preganglionic fibers are pretty short because all they're doing is they're coming out of the spinal cord and they're going into the paravertebral chain ganglion, not very far. Versus parasympathetics, they have to go really long way because there's a cranial sacral outflow. So we have cranial nerves that have parasympathetics, and then we have pelvic nerves that have sympathetic or parasympathetics on them. So you're going to have this weird outflow here. So we got to get all the way from the brainstem down into our intestines and everything, our organs down here in our abdomen. So they're going to have really long preganglionic fibers. And then, so they'll synapse really at the effector organ. So you have postganglionic fibers after the synapse. Just because we went to that paravertebral ganglion, remember that sympathetics go everywhere. They're all over the body. So we need really long postganglionic fibers to get wherever we're going. And we can do that in a lot of different ways, which we'll talk about specifically in the sympathetic video. And then parasympathetics have really short postganglionic fibers because remember, they synapse usually at the effector organ. So they don't have to go very far. And they do this through a really unique junction. This one is going to use varicosities. And so you see these little bead-like structures here. Those bead-like structures are going to be giving off that neurotransmitter throughout all of them. So we have a much wider area for that to happen. This is important because with sympathetics, we need this to happen quickly. All right. Now, with parasympathetics, you don't normally need as many nerves to contribute. And that's because there's a lot of gap junctions that are a part of this. So think about your heart. We don't need a whole web of parasympathetic activity to it. We just need a couple because it's going to propagate through that cell, right? Now, sympathetics, we want to really drive home. So you'll see a ton of those. So with the heart, you'll see cardiac acceleratory nerves. So that's the video. Let me know if you have any questions in the comments.